Welcome to part 1 of our exploration of geometry, angles. I don't know how you think of geometry, but for me, it's kind of like playing a game. There are basic rules, which for Euclidean geometry are definitions, axioms, and postulates, and then we play our game according to those rules. For instance, suppose we have a game where yellow scores at this end and orange scores at this end, and yellow gets 2 points every time they score, and orange gets 2 points every time they score. That's the beginning of one sort of game, but we can change the rules, and we can say behind this line, yellow gets 3 points every time they score. And behind this line, orange gets 3 points every time they score. A change in the rules changes the game. So for example, orange might be bringing the ball down the court and get close enough to their goal and think, I could shoot from here and get 2 points. But if I back up, the defender probably won't come with me, and perhaps I can try for 3 points from here. That strategy of driving and then backing up isn't one of the rules, but it's kind of like a theorem. It follows from the rules. It's something that we can conclude from these first principles. So let's begin our exploration of geometry. Here we have 2 points, and the first postulate says a straight line can be drawn connecting any 2 points. Now let's construct a perpendicular line to the first line. Postulate 4 says all right angles are congruent. So that right angle is the same as that right angle and these right angles. All right angles are congruent. So if all the way around is 360 degrees, then a right angle is 90 degrees. All we knew is the angles are congruent, and so if we start with a total of 360 degrees, then each right angle must be 90 degrees. And that means a straight angle is 180 degrees as it's 2 right angles. Now, who says all the way around is 360 degrees? And the point is, it doesn't really matter. It has to be something. If we settle on and agree that it's 360 degrees, then it helps us speak about the system. It's part of the basic rules. And given those basic rules, we play. So let's go back to our line, and instead of a right angle, let's use an angle that doesn't intersect at a right angle. I don't know what that angle is, but some other angle. It's not 90 degrees. Let's call it theta. Then what's this other angle? Well, if a straight angle is 180 degrees, then this must be 180 degrees minus theta. And I'm kind of casual. I say, what is this angle? I mean, what is the measure of this angle? So let's change our perspective and use this orange line as our straight angle. If this top left angle is theta, what's the bottom left? Well, again, it must be 180 minus theta. And to complete the picture, if the top right is 180 minus theta and the bottom left is 180 minus theta, then using either straight angle, the bottom right is 180 minus theta, which is, of course, theta. So what we've seen is these two angles are the same, and these two angles are the same, and that's what we call vertical angles. And what we've shown is the measure of vertical angles are equal. And that's our first theorem. We took the rules and things we derived from the rules and came up with something new. That's the activity of play. Next time, we'll show that the sum of the measure of the angles in a triangle is 180 degrees.